Okay, we got perimeter and area today. This is going to be a big section and lots of formulas. So let's get with it. Perimeter, of course, is the distance around the edge, outside edge of a flat object. And it is reported as linear units. So we're going to have all kinds of units we're looking at now. We've been measuring in linear units. When you say this is 15 inches, that is a linear, just a plain old inches unit. Later on today, we're going to be looking at square units, where it would be 15 little squares up inside of a box or something like that. So, something like that. 15? Yeah, okay. So, what's the perimeter of this shape? When it's in blocks on a graph, of course, you can just count it. Going around the edge, like that, every little step. You don't worry about inside pieces, just what's around the outside. And it makes 24. Now, of course, in ACT, they're going to separate it and put a little algebra with it. So this is not too bad. Finding the x of this when you're given the perimeter, P usually stands for perimeter in this case. So all the sides are supposed to be added up. We're going to put our x's together first. That'll be 4x. We're going to put our regular numbers together, 10, 15, 10, that's 35, equals a total of 55. Work it out. And 4x equals 20, so the x is 5. That would make each of those pieces 10 as well, if you plug it back in. So easy, easy. All right, now what gives people trouble are problems like this. I want the perimeter of this shape and it's missing a side. Well, think about it as not just like a L shape or an R shape. Think of it as two rectangles stuck together. And you can separate the rectangles. You can cut it across here and make it into two rectangles, or you could cut it up and down, but you don't need to do it both ways because that makes 3 rectangles, and that's just making more work for you. So either do it sideways or the up and down. Now, if I do it like that, then I look at one rectangle right in here, and I say, okay, what's opposite to that? The opposite sides of a rectangle match. Remember that from the last chapter. So this should have a 5 here, and the opposite side here would be 3. So that would make this whole top piece an overall length of, yep, what's here again? Segment addition postulate. That would be 8 up at the top. And most people can see that. I'll look at it and say sideways piece, sideways piece. This is the whole sideways piece. So little piece plus little piece equals the whole thing. So think of it like that. And look at the 6 and the 4 add up to be that 10. Now you can add up these problems. A quick thing to do when you do have this type is to save yourself a little time. If it is just like a basic stair step, and if you turn your head sideways, you can look at it as like a little step stool, right? You can't do it if like a piece is cut out and you got to add this and this and this because this is all open. But when it's just a basic stair step like this, you could do a shortcut for your perimeter and just keep in mind this side's going to match the 3 and the 5, so it's like being at 8 across from an 8 and a 10 across from a 10. And so that can be, putting your head a little bit faster. This is 16, this is 20, so that's 36 for your whole perimeter instead of just adding all these up. I've seen problems before where they did that with a little algebra and you couldn't find the missing side like we just did, but you could do that total and figure it out. So find the perimeter here. Now see, this one you couldn't do that little trick because I've got a little square that's been cut out right here. So this will be 3. What would this piece be up and down right here? You got 5 going up and down. You need that piece going up and down. You got another 5 going up and down, but you got a 14 over here for the whole thing. So that missing piece right there needs to be 4. Now we can add them all up. 15 at the top, 15 at the bottom is 30. You could have 14 and 14 with those two edges, but you also had this little cutout piece, so that'll be 6 and 6. I mean 3 and 3, 6, and added up. So that's what? 8, 14, 5, 64. Okay, I hope that's right. All right, so your area formulas, we have all these formulas, and the ACT, of course, expects you to know that formula, triangles, parallelograms. I've seen them where they give you the trapezoids and the polygons, but not every time. So if you can have all these formulas memorized, it would be better off. All right, remember when you're doing area, it's not going to be just a straight line anymore. You're saying how much is inside of this rectangle. So it's not just going to be like 4 feet inside of it. It's going to be measured in a different way. It'll be blocked off into little squares, and it's always square units, whatever it is. It could be square inches, square feet, square meters, square miles, but it's always in little square blocks, because those, if you think about it, when you shade in that square block, then you get an area. You get a space there that's filled in. So that's how you measure area. Every time area is involved, you're going to be thinking square units, and even your answer is going to have a little square by it to indicate that you've got square units. You wouldn't say I've got eight squares. You'd say I have 8 square feet, and you put that little square on the side of the feet. That means it's not a straight line 8, it's 8 little boxes like we've got here. Okay. All right, so of course a rectangle, you might have learned it as length times width, but we're going to use base times height. Same thing, but we're going to use base and height for just about all of our formulas. Remember, the base does not have to be at the bottom. The base can be anywhere. The rectangle matches opposite sides, so this will be a base up here at the top as well. But what we do with this in all of our formulas is remember that the base must meet the height at a right angle. So say that out loud. Nobody's listening. You're just sitting there at home bored. All right, base must meet height at a right angle. So when you see your right angle, that's your base and your height touching right there. And you don't have to worry about anything else, because that's usually all you need. All right, so base times height. So if we had 12 and 8, of course we would get 96 square feet, because it's the area. So here, what's our base? Okay, nothing on the bottom, but it doesn't have to be on the bottom, right? So 16 is a base and 10 is your height. There's your right angle. So base and height are meeting right there, 160. All right, a square. Now a square can be treated like a rectangle when you're doing your formula and do base times height, but most things that I've seen on the ACT, they want you to think about it as a side. The side length, of course, is like a base, but you're only got one side you need to worry about, because it's going to match. It's a square, right? Square all the way around. So if I got 5 here, I'll have 5 here and 5 here, and it'll be 5 all the way around. But we just need to square that number. 5 times 5, 25, or 8 times 64. Can you work it backwards? If I give you the area, what is the side going to be? Well, just write your formula. If you write your formula, you can work the formula backwards. That doesn't matter. Let's see if I can clean this off. And you can say my area formula is the side squared. A is what I know. Area is 81. So how do I get S, side? If I need just S by itself, get rid of the square by square rooting. And so that's going to be 9 feet. And it goes back to just a side length. 9 feet, one direction. Can I work it with the other problem? Area of a rectangle, base times height. So my area is 24. My base or my height, doesn't matter which one. Base, we'll say, is B, and the height is 10. So get B by itself. Divide out 10. Divide out 10, you get 2.4 for the base. And of course, that's not drawn right, but it's close enough. All right. What about that? Ooh, okay. Same thing. What's the formula? Area is base times the height. The area is 40x minus 40. The base is 2. The height Remember, if it's a little adding there, we need to group it. 5x plus 10 in a group. This is just going to sit here, 40x minus 40 equal to distributive property. So 10x plus 20. Get your x's together, minus 10x, you get 30x. Get your 40, move the other side, plus 40, you get 60. And so x is 2 when you divide it out. Lots of fun there, yeah. All right. There's a little bit neater that way. All right, parallelograms are next. Now, parallelogram looks like a rectangle where the sides are leaning over. So we don't have a right angle here. So when you have to find the area of a rectangle, you're going to have a height that's drawn on there special. Now watch what happens. There's the height going straight up like that. If they don't have it on the outside like that, think about what could happen. It could be on the inside, outside, doesn't matter. The height's got to be on there. And what they could do is cut off one end and move that end to the other side, and your triangle fits perfectly on there. And it's the same formula as a rectangle because it's the same amount of space. But your height has to be going straight up and down at a right angle. So we're looking at this drawing, easy one. The base is meeting the height at a right angle, so that's your base, that's your height, 77 square units. That just means it's generic. It could be inches, feet, meters, whatever. Just units, whatever it is. So what if it looks like this? We need a base and we need a height. Which one's which? If I got a right angle here, and remember parallelograms, the opposite sides match, 9 and 9, 19 and 19. What's meeting at the right angle? 15 and 9. That's your base. That would be your height if it was turned the right way. So
you probably do your roll.
So next we're going to look at a triangle. So if you take a rectangle and you split it with a diagonal, you get two triangles. So is the area half of a rectangle? Yeah. And if you think about the formula, the area of two triangles is equal to the area of one rectangle, and you get the triangles by themselves, you're going to divide out the two, and it'll cancel, and you're left with base times height divided by 2. Or some books will say 1/2 base times height. Either way, I like base times height divided by 2 because it's quicker to put in the calculator. Easy enough? Same rule applies. The base meets the height at a right angle. So here's my base, here's my height. Base times height divided by 2, and you get 20. What about when it's like this? Same formula. Base times height divided by 2. What's the base and the height? Meeting at a right angle, so 12 times 10 divided by 2 is 60 square meters. Okay, and that's just the way you say it, square meters, not meters square. Who cares, right? All right, so here's one more. Base times height divided by 2. We got a base, but do we have a height? No, we got something here, but nothing over here meeting at a right angle. How are we going to find that other side? We have to have it. There's no way around it. But what do we see here? A right triangle where two sides are given, and you're looking for the third side. One more time, Pythagorean theorem. Filling it in, working it out, getting your answer to be 16.58. So you plug that in for your height. Divide it all by 2. Calculators are wonderful. 25 times 16.58 divided by 2. 207.25. Nothing to it. Alright, trapezoids are next. Trapezoids are weird little things, but they have a formula that's very similar to what we've been doing. Bases are going... I like that. It rings on me too. Alright, so the bases are never going to match. So what we're going to do is we're going to kind of take an average. What do you do to take an average? You add them up and divide by how many you got. Well, what is doing? What's happening right there? You're adding them up and dividing by what you got. 2 bases divided by 2. So the whole formula is you add up the bases, then multiply by the height by 2. But you can do this average part first. Get your average and then say times the height. Alright, so here we've got our 2 problems. So it'll be 14 plus 22. Alright, add it up, divide by 2, and then times the height of 8. 144. Why did that one have sound? I don't know. Make sure on your calculator you get this answer first. Unless you're putting in all the parentheses and all that, it'll be a mess, so be careful. Alright, where's the base and the height? Uh-oh. The bases have to be parallel, so the bases have to be 24 and 18. Add those up and divide by 2, and then the height meets those bases at a right angle. I can give you one right angle, but the other one's going to be there as well. It has to be 2 of them. So that'll be times 12. Yeah, ooh, that's special. So if it's isosceles, then you can do a little more work with it. I've got matching sides on this isosceles trapezoid. And that means these little parts down here will match as well, these little triangles. So I am missing my height. Uh-oh. Remember the base with height? So I'm still going to have 18 plus 24 all divided by 2, but I don't have a height. What am I going to do? I'm going to bring this 18 down. You see this big old rectangle right here? 18 will come down and match 18 here. So 24 minus 18 would be 6. And guess what I get to do with that 6? Split it into 2 equal pieces. 3 and 3. So now I've got this little right triangle right up in here. And it's got a base, it's got a bottom of 3 and a hypotenuse of 12. I get to do Pythagorean theorem one more time. So leg squared plus 3 squared equals your 12 squared. That's 9, that's 144. Leg squared, you're going to subtract 9, you're going to get 135. And your square root of 135. You type it in. 11.61, so that is your height, 11.61. You still got to plug it in. Yep, it's a crazy one this time. So all that times 11.61. Let's see if the answer pops up. No, it didn't pop up, so let me work that out. 18 plus 24 divided by 2 times 11.61. 243.8 for that last problem. Okay? Alright, regular polygons. Now remember, regular meant all the sides matched, all the angles matched, okay? You have a special thing that's drawn, that can be drawn on it, and it's sort of like a radius, but then it's sort of not like a radius. Alright, it goes from the center of your regular polygon and it hits the side at a right angle. So it's kind of like a little half height, if you want to think of it like that. But I always look at it kind of like a radius. It's called the apothem. See it right there? Apothem. And I'm not saying the thing that runs out in the road and, you know, freaks you out with the big teeth. The apothem is a segment that goes from the center down to the midpoint. It's actually midpoint, so these two sides match here as well. Alright, on each side. and you have a right angle there too. So the formula for any regular polygon, so it can be other shapes like triangles and rectangles, not rectangles, it's not regular, a triangle, equilateral triangle, a square, pentagons, hexagons, all that. When you have those shapes and they are regular, they're the perfect hexagon and all that, you use this formula, the apothem times the perimeter divided by 2. Now that's area for the A right there, but the little a is the apothem. So here we have a hexagon. Our formula, apothem times perimeter divided by 2. So the apothem is 5. The perimeter is not 8. What is perimeter? 8, 8, 8, 8, 8, 8, all the way around. And so you get 48. All right, and then 5 times 48 divided by 2. 120. Easy, easy. You don't even need a drawing. Compute the area of a regular triangle with an apothem of 14 and a side of 10. So area equals apothem times perimeter divided by 2. 14 times, what would the perimeter be? Not one side. It's a triangle, 3 sides. So 10 times 3 gives me 30 for that perimeter. If you need to, draw it. Each side will be 10. There you go, 30. Divided by 2. And that makes what? 210. So a little extension here, ACT kind of level. You can still have what's called a radius. And the reason why it's called a radius is if a circle was drawn with the same center point and it would fit inside all perfect like that, then that would be the radius of that circle as well. So that's called the radius, even if it's on the pentagon as well right there. But we want the apothem right there so that we can find our area. All right, well, let's think about what happens with this. It's going to have 40 all the way around. So we know our perimeter, but what's going to happen, what does that apothem do to this 40 down here? It splits it and makes 20, doesn't it? Oh, and I think I have to give you a radius too. All right, so it makes 20 right there for that split. So now, how do we find the apothem? Pythagorean theorem right there. And that works out to 12, I believe. No, 15. Not bad. All right, so 15 for that side, and you can work it from there. Cool? Yes. All right, now we're back to our combined shapes. So remember how we found the other side. This bottom piece is 3, bottom piece is 5, so this will be 8, and then up and down will be 10. But now we're really wanting to cut it for sure into rectangles. You can cut it one way or another and bring that missing side up. So we may not need that 8 and that 10 over there, just depending how you cut it. If I bring that 3 up, then I've got 3 right here for this top part of that rectangle. On this rectangle, look, I've got everything I need. I got a base and I got a height, so that's going to be 30. But on the other one, I got 3, and then I did need that 10 over here from 6 plus 4. So you might just want to put them all up there. Just remember, if you go ahead and do that, putting all the parts, you remember we had 8 up here. If I draw that line and cut it, then the 8 just got cut up. And take that number out so you won't be using that by mistake. This side's 30, this side's 30. So what is the total green area? It's no L shape. We just have to combine the pieces, composite figure, and it's 60 square units. Just add those 2 pieces up. Our final shape is a kite. Yay, it's the final one. And a kite, remember, it always has this diagonal on here gets cut in half, and it matches on both sides, so it's cut in half. But the top diagonal running up and down is not cut in half. You don't know what's happening. It could be, 6 goes with 12, but it could have been 7 with 12. It didn't matter. That up and down piece is never going to be cut in half. It'll just get cut. But it doesn't matter because we're looking at the whole length of the diagonal and the whole length of the diagonal there. How long is the blue? 10. How long is the yellow? The formula is diagonal times diagonal divided by 2. So it's kind of like a base and a height. They are meeting at a right angle, aren't they? So remember that you got the whole length that you're looking for. 10 and the 18. Divided by 2 and you get 90. Easy, easy.